Geometry, Chapter 1, Section 5. This is example 4, the last example I'm going to go through. I'm going to go through these probably kind of fast, though. Determine whether the following statements can be justified from the figure below. Explain. Justified. Okay? So you can't just say, because I said so. So VYT, VYT is 90 degrees. Is there any way possible we can justify that VYT is 90 degrees? Well, I say yes, there is. You know that XYV, right here, this XYV, okay, XYV, that angle, is equal to 90 degrees because it has the little red triangle or square in the corner. The little red square means perpendicular, perpendicular means 90 degrees. You know that XVT, angle XYV, and angle VYT are a linear pair, right? They are a linear pair. And if they're a linear pair, that means that they have to make a line or make 180 degrees. So that means if one of them is 90 degrees, the other one, 90 plus what equals 180? Well, the other thing has to be another 90. So we have justified it, we've explained it. It does have to be 90 degrees. So yes, this also is a 90 degree right there. Okay, determine whether the following statement can be justified from the figure below. TYW. TYW. Oops, that doesn't look very good. From T up to Y, out to W. And TYU. Let's grab a different color. T to Y to U are supplementary. Now, supplementary, what's the definition of supplementary? That's angle 1 plus angle 2 is equal to 180. The sum is 180. So 180 degrees, and we know that they are a linear pair. And we know a linear pair means they form a line. And we know lines are 180 degrees. So we know they're a linear pair. And you know a linear pair is 180 degrees. So the sum, lines are 180 degrees. Let me go back. The lines are 180 degrees. And since they're a linear pair and lines make 180 degrees, then these two have to make 180 degrees. So they have to be supplementary. So this is also a yes. Okay, VYW. VYW. V to Y to W. And T to Y to S. T to Y to S. Are they adjacent? Well, they're not next to each other. They share a common vertex, but they don't have a common edge. So no common side. So the answer to this one is a big fat no. Let's look at a different picture. Okay, is GHM, G to H to M, and M to H to K, M to H to K adjacent? Are they adjacent? These would be adjacent. Yes, they have the common vertex, common vertex of H, and they have a common side. And their common side is this HM ray. Okay, so they've got a common vertex of H, common side of HM ray, and they no points are inside of each other, right? So G is not in between M and K or anything. So yes, this is a good one. Yes. Okay, K, H, J. K to H to J, and G to H to M. G to H to M. Are they complementary? Is there any way we can prove complementary? Well, complementary means that angle 1 plus angle 2 is equal to 90 degrees, right? That's what our complementary definition is. The sum of the angles is 90 degrees. Is there any way we can prove that those two angles add to 90? I don't think so. This GHM with this MHL would add to 90 degrees because we've got the right angle here. We know they're the same measure as each other, but there's just not enough information to get us to the fact that they would add to 90. So again, a big fat no. Okay, GHK, G to H to K, over there, and J to H to K, J to H to K. Are they a linear pair? Well, linear pair means that a pair of angles, two angles, form a line. Well, GJ is a line, so yes, the two angles have the common vertex, they have a common side, and the other side that they don't have in common are opposite rays, so they form a line, and so yes, it forms GJ as a line. So this one is a yes. Yes, you can determine it. Okay, so again, this is time for you to pause. I've got 3 of them for you to pause and test and see if you've got it right, and then come back and check your work. Okay, determine XAY, X to A to Y, can be assumed from the figure. There's nothing on this figure that tells us any measure of any angle, so there is no way you can tell that that is 90 degrees. It sure looks it, but it's formed by two intersecting lines, but we don't know degrees, so that's a no. We can't say that for sure. How about this one? Is TAU complementary to UAY, to UAY? Complementary means angle 1 plus angle 2 is equal to 90 degrees. Are those equal to 90 degrees? No, those would be equal to 180 degrees. That's a no. Okay, and the last one, again, pause it, come back when you're ready. Okay, UAX, and the other one is UXA, UXA. Are those adjacent? That would be a big no. Not a common vertex. This one has a vertex of A, this one has a vertex of X. So adjacent angles have to have the same vertex, and then their sides have to be the same.